So, right, you already said everything, my name, the title, so I can just jump into it. And I'm an example guy, so I want to kick it off with an example. It's business-wise probably not the best, but it's actually used within that context to show different things like sagas. I come back to that later on very often. So it's kind of the canonical example for doing this. So I want to use that as well, even if it's not what probably you're doing. And let's assume you have functions in order to, for example, book a rental car, and you have a function in order to book a flight, and you have a function in order to book a hotel, and then you might want to offer something like a trip booking, right? That's the problem we want to target first. If you're in that situation, you have to have these functions to collaborate in order to do something, and that's actually what we're seeing happening. I mean, we're like cutting functionality into ever like shrinking pieces, like functions, and then we have to have them collaborating in a meaningful way. And there are a couple of ways of doing that. I'm actually not elaborating on that too much, but I'm still seeing that around that. I mean, the easiest option would be you have these functions in, for example, in JavaScript, and you can just merge them and deploy them at whatever, one Lambda or one Google function. Of course, that's possible. It's one option. I don't want to go down that route. It normally has a lot of like drawbacks you don't want to have, because then it's like one function. You can't evolve that independently. You can scale it. Can't scale it independently. It's really not decoupled at all. So normally that's not what you do, but for some use cases it's probably still a very, very useful thing. What's much more happening is that you probably want to call other functions in what I called a choreography here. It might be like direct calls, but very often it's what you probably heard in the last talk from Niall from Confluent, is that you probably want to use some queues or some events in the middle. It might be something like Kafka, but it could also be Kinesis or whatever it is. Then probably you like create an event that whatever something has happened or something is to happen, and you have this kind of call chain. While this is possible, normally you don't need an extra framework if we don't count the messaging. It's sometimes hard to understand bigger like call chains afterwards in order to see what's happening. And coming actually back to that, like in the second half of the talk in a very detail. So I don't want to push that much forward at this point. But that's an option. And the last option here, I called it orchestration or coordinator function. That's actually what I see happening a lot, is that you, for example, build your trip booking function. And then from that function, you call other functions in order to do something for you, like first, please book the rental car. And then the next thing you should do is probably book the hotel. Okay. Well, this is definitely possible. You should have one thing in mind. And this actually is also kind of the title picture for the talk. And that's my picture for distributed system. That's my metaphor. And these, like this small hut over there, this one, that's your one function or your one microservice if you're doing that. That's kind of the one component where it's cozy to be, right? You close the door, you have a heating, you have probably transaction management, you know what's going on there, you don't have multi-threading and these kind of things. So it's pretty cozy, but when you open the door, then you meet that ocean that's very rough, and that's the network. You know, the policies of distributed computing. I mean, we're at Serverless Conf. You definitely should know them. And the first policy is the network is reliable. Of course it's not, right? So you can't rely on like every call you make that this is successful at that time. And very often, and that's the hardest part sometimes, it's not a binary thing. The network is not there or it isn't. It's a bit there or a bit faulty or like turns thing around. So there are weird things that can happen because of the network. My favorite piece of, let's say, my favorite picture to show that is actually this one from InfoQ. They're doing that trends report once in a while. And there was the one from 2019. And one thing, I mean, it's not serverless, actually, not functions as a service, but they have microservices in the late maturity. They put it there. That basically means most people are at least adopting it. But there's one thing which is really interesting in that graph, which is correctly built distributed systems. That's early adoption. I mean, it means everybody doing distributed systems, and especially with functions, you're doing distributed systems, but nobody really understands how to do that well. And that's a problem. That's definitely a big problem we have to think about as an industry. And just to make an example, in this case, if you want to call out like for booking the hotel, that might fail, right? So you might not be able to reach the other one. Okay, that's not too hard to solve, right? Then we do a retry. Like, okay, we get the network exception, we just do a retry. That's relatively natural. There are frameworks to support that, so it's not too hard to do. Okay, we can handle that. One thing which is not very often starts to be a problem then is that in order to be able to do retries, you have to have a function which is idempotent. Idempotent means that you can call it twice without bad things to happen, right? It's very often very simple that you need some kind of ID which can be used in order to detect duplicate calls. So when you have an API, and very often if you're building that function, you can't really influence the API of that function because that's probably another team, that's probably something that's given. If you don't have that trip ID here, then you have a problem, because then if you retry, you might book the same hotel twice, right? And that's important. Idempotency is, I think, one of the trickiest part of most of the distributed systems today. It made me come up with that slide. I thought about that for quite long. You can judge afterwards if you like it or not. But I was vegan, or I ate vegan for roughly half a year. That was 6 or 7 years ago, before I had kids. Then I could do that. My favorite dish is that one. You can do zucchini noodles. I always forgot that British term for zucchini, but you probably can translate that, right? Yeah, right, exactly that. I keep saying zucchini, otherwise I get confused. Sorry for that, but you have a picture of what I mean. So you can use, there's a special slicer. So you can use the zucchini, use the slicer, then you get noodles out of the zucchini, right? And then you add some sauce. It's very tasty. And there, in the cookbook, they say, okay, you can eat as much as you want from that dish. You can eat it in the evening. It's that, the book is called Vegan for Fit. And they really look for that, like what can you do in the evenings and so on and so forth. And you can eat as much as you want. So if you eat a plate of like zucchini noodles and then you forget about it, no problem, you eat another one and you forget about it again. So you eat another one. So it's totally idempotent to eat zucchini noodles. That's not true for pasta, right? That's the best metaphor I came up with for idempotency. If you have a better idea, let me know. I'm open for suggestions. But for me, that's currently what I work with. And the whole thing, why do I tell you about that, is like, remember that. Idempotency is so super important. I see so many projects struggling just because they don't have that interface. They don't have the possibility to pass on an ID they generated in order to make everything idempotent, right? So that's super important. Whenever you build a function, think about idempotency as kind of the service provider. Good, idempotency. But that's not it. So we're still in a distributed system. And there's another thing which is quite ugly about distributed systems. So let's assume you get that network exception when you call the other function. And it's a network error. Then you have no idea which of the 3 scenarios just happened. It could be like the first one, like you tried to reach the service, like the other function basically, and you didn't succeed because there was a network problem or the function wasn't up or whatever happened, right? It didn't work. Okay. The second possibility is like you reached the other function, it started to work, but then it exploded for whatever reason, or it got shut down or whatever. And you have no idea if that function committed its own transaction or not. You don't know. Or the third possibility is like everything worked perfectly fine, but the response got lost in the network, right? And you can make the same example, by the way, not only with like synchronous REST communication or whatever, you can make the same example also with events or messaging. You send out a message, you never get back a response. You have no idea if the other peer did something for you or not, right? So in our example, it means whenever we say, hey, book hotel, and we get a network exception, we probably retry 2 or 3 times, it doesn't work, and then we give up and say, hey, sorry customer, we can't book you the trip, we might reserve the hotel, right? And that's important at least to keep in mind. There are a lot of use cases where you can ignore that. That's fine if that's a conscious decision to ignore that situation. I'm fine with that. But you have to make the decision like yourself. And very often it's not a good idea to ignore it. So you might have to have some kind of cleanup mechanism, like where you say, hey, okay, I couldn't book the hotel, but I'm not sure if I probably booked it, so I cancel it or ask for it or whatever. But there must be some logic in order to take care of that. And you see where that's heading. That's not like simple, right? So you have to have a lot of logic, which you only have because of that distributed systems. But you have to think about that. There are a couple of overall weaknesses. Now, I assumed actually currently that we are basically using REST communication probably via the API gateway, which is actually what I see most of the projects I see doing. If they're having whatever Lambda and then API gateway and they're doing synchronous REST. There are a couple of drawbacks of that architecture anyway, which you should be aware of. So first is like what's sometimes referred to as latency creep. So if you're doing that, if you're having your trip function, and this is calling out other functions in order to do something for you, you probably have latencies of all of them. And if you do that in a sequence, because you want to do it in a sequence for business reasons, for example, then you add up the latency, right? That's a very easy calculation. You just have to do the math. In the serverless world, it even means you pay for a quite long execution time in the trip function, because it's simply waiting for the others to return results, which is probably not a good idea. The other one is, I like the term availability erosion. It's not like a given term, but I heard it a couple of times, and I like that actually. So that's kind of probably if you're in the cloud world, you probably have a very high availability of the single functions. But even there, even if you have 5 niners uptime, there is a small percentage where you're not available or where you're redeploying or whatever. And normally the different functions you need are not coordinating on that. Hey, our whatever, 1% outage is tomorrow at exactly 3 p.m. No, that's not how it's working. So it adds up, and that means it brings the overall availability down as well. So these are a couple of things you should at least keep in mind. That's normally a motivation where workflow as kind of a technology kicks in, that you say, okay, there are a couple of things we now have to do. We have to, first of all, we have to do that retrying, we have to do that cleanup, we probably have to wait for things, but we don't want to block a running function and pay for all of that. So there are a couple of things which motivates a lot of people to go for something like workflow, like in AWS, for example, step functions. And then you have kind of workflow engine normally where you express the exact logic, how that should happen, and how you want to orchestrate the other functions in order to do that. Okay, that's the whole idea there. I want to make one thing transparent. I normally do that at this point in time. So my own opinionation is basically I'm, let's say, the workflow guy. I'm working with the workflow for more or less all my life. I contributed to different open source workflow engines. So that means I look at most problems through the lens of workflow, right? So that's probably good to have in the back of your head when I'm talking about that, and when I later on also compare choreography to orchestration. Right, and I co-founded Camunda, which is also an open source workflow automation tool vendor. We are also started to have a SaaS offering in the cloud and these kind of things. That's why I'm totally interested in the whole serverless function orchestration space. If you want to reach out to me, that's my email address. Send me an email, tweet me. I'm happy to discuss anything. And if you use something like a workflow engine, you can express the workflow in different languages. I'm not really focusing on that too much. I'm using BPMN here. That's an ISO standard. If you use AWS, you might use the Amazon State language. So there are a couple of differences, but whatever you use, then you get this kind of workflow, like where you define a clear sequence. Hey, first of all, I want to book the hotel, then I want to book the car. It's really tiny, that monitor. And then I want to book the flight. right? So you define that, and workflow engines then can take care of a couple of the heavy lifting around retrying, around something I call stateful retrying that I find interesting. Workflow engines can keep state persistent. So even if, like, for example, the rental car function is currently whatever, has a downtime, even for hours, that's not a big problem. Then the workflow just keeps waiting there and picks it up whenever it comes up, right? So it can wait for a long time. And it's not blocking anything. It's not a thread being blocked or a lambda being called for minutes. It's really state somewhere stored, but that's actually not your problem here. But it's persistent, right? Let's talk about the next really interesting topic in that area. If we are there, if we are saying, okay, I had that workflow, let's talk about ACID. I don't ask, but I ask who's familiar with ACID, as I just put it there. Half of the people, okay. ACID is something you learned probably if you're a bit older in university about transaction management of databases. So ACID properties, and that's what it stands for: atomicity, consistency, isolation, and durability. It means if you have a database transaction, like a classical relational database, then you have something like, hey, I begin a transaction, I do a couple of things, and then I commit or I roll back. And everything I do then is, first of all, it's isolated. So if you have different threads, there are isolation levels. So normally another thread don't see any of my changes unless I commit it, right? So it waits for everything. And it's atomic, all or nothing, right? If I say roll back because of an error, none of the changes is really like getting into production. It's not there. That's the important things here. Durability makes sense for a database, should be there like tomorrow again. And consistencies, normally they can check constraints like this shouldn't be null, there's a foreign key, all these kind of things. Okay, these are ACID properties, which we know from databases. So back in the days, like 10 or 15 years back, a lot of people used these kind of ACID transactions to program for consistency in these kind of business problems. Because, for example, if we say we want to do like the whole trip booking in an all or nothing semantic, because if, like, for example, the flight booking doesn't go through, the flight is full or for whatever reason, it doesn't make sense to have the rental car in the hotel room, right, if I can't fly there. And that's the idea. I mean, you can translate that to business problems you have. So in this case, I can't simply say rollback, right? Because I don't have technical transactions making that possible. There are different probably REST calls, or I even send messages around. So it's not a technical transaction I can leverage here. I don't think I have to prove that point, but I love that paper, so I like normally pointing to it. There's a really good paper by Pat Helland. Pat Helland at that time worked at Amazon. Now he works at Salesforce. And he wrote Life Beyond Distributed Transactions, because at that time it starts to vanish, but it's still very often there. There was a belief we can solve this by some technical infrastructure, by a transaction manager that's kind of powerful, and can just simply do that, some piece of technology. And he explained very well why this will never work. It doesn't scale, it's too complex to handle. There are things like two-phase commit or three-phase commit protocols. Nobody understands that. So, and basically you should simply not do that, right? So the big question is, and we're getting closer to answering that, but for a decade or so, nobody really thought about that, is how to solve that problem of having these different steps in an all or nothing semantics. What I like actually is, if you look back in history, there's a good keynote from Eric Brewer. He's one of the Google guys. And he already said in 2000, so this is where the date is, like 2000. That's pretty old already. But at that time, he already said, we have to forfeit C and I, and he refers to consistency and isolation of ACID in order to build really scalable systems, basically. That's what he said. So it's not new knowledge, but we see that now being applied. And that's actually, I think that's pretty good. He claimed that, like, we shouldn't do ACID, we should do BASE, never took off the acronym, basically available soft state, eventual consistency. So that didn't really work, but the idea is totally true. And that basically means we change how we think about transactions and consistency, which is a very fundamental change, actually. That we say, OK, we can book the car, and then we book the hotel. These are like single transactions on its own, right? But I don't have an overall transaction. I have like a temporarily inconsistent state, right? I accept that. This breaks the isolation of the asset properties. As soon as I book the car, it's booked. And if there's a small car agency where I fly to, probably that was the last car. So the next customer who wants to book a car doesn't get any because it's blocked for me, right? It breaks the isolation. But I make sure it's consistent at the very end again. So after booking the hotel, I'm sure it's done. And if the booking of the hotel doesn't work, I have to clean up. And that's eventual consistency. There's a really awesome book. Probably a couple of you already read that. If not, I totally recommend that one. Designing Data-Intensive Applications from Martin Kleppmann, here from the UK. Really good book. And he had a talk at Strange Loop in 2015. That's on YouTube. I personally liked that talk very much, but there are a couple of other good talks from him as well. But I borrowed one slide from that talk. And he said, OK, if we don't have cross-service or, for here, cross-function transactions, right, then we basically have two options how to deal with that. The first is we can have compensating transactions. I will basically explain that in a minute. It basically means I roll back on the business level, like canceling the car again. That's kind of the rollback, right? I booked it and then I cancel it because I don't need it anymore. That's compensation. And the second one is also interesting, it's apologies. So we don't avoid these kind of problems, right? That's kind of the overbooking, what airlines do, right? They probably let you in, but then, oh, damn it, sorry, we don't have space for you. There's a compensation, we apologize. That's basically the idea. These are other strategies than we had in the past where we did asset transactions. It's a bit more complicated in a way, but you get scalable systems, so you get a reward. If you look back at our example where we do the trip booking and we say, hey, the flight booking doesn't go through, what we have to make sure is we have to make it consistent again. In this case, it means we have to cancel the rental car and we have to cancel the hotel. Okay. One important consequence of that is you have to have the functionality to undo things. If you're working with legacy systems, for example, which are like 20 or 30 years old, very often you don't have proper compensation methods or services because they haven't thought about it, because you have asset transactions. Okay, so that's important. And that's very often referred to what I said at the very beginning, the saga pattern. So if you hear the saga pattern, that's actually what it's very often named. So it's a good, if you want to Google your way around saga patterns, I think the best start there. It's named after a paper in the 80s, which talked about long-lived transactions at that time on databases, but works pretty well in distributed systems. Okay, and then if we want to implement that, we have basically two options, choreography and orchestration. I very briefly touched on them at the very beginning. Let's look at that example, how it looks like in a choreographed and in an orchestrated way. Because I find that very interesting. And it's kind of a proxy discussion for how you coordinate your functions anyway. So let's assume I have these functions, right? And then I probably call the first function, say, hey, I want to book that trip, right? What this function could do, if it's really event-driven, and I don't go down the REST route here, it's event-driven, for example, in this case. Basically, it could emit an event, which basically says, hey, there was a trip requested. And then the hotel service could say, oh, if there was a trip requested, I need to book a hotel, and then the hotel is booked. So the rental car service knows, oh, if there was a hotel booked, I just need to book the car, and so on and so forth, right? And this gives kind of an event chain where finally, if everything is all good, you probably end up with a very happy customer because you booked the trip, right? There are, I don't go down that route today, but there are a couple of different ways how you, to which events you want to listen. Do you want to do it in parallel? So that's not the only possible flow, but that's the one I want to use for today. So if I do that, and if now that was a happy case. If I look at the like the problematic case, it could be that the flight booking doesn't go through, and then you have to basically do that in kind of the reverse order. Hey, the flight booking failed, so the car service has to remember, oh yes, I booked a car for that trip, now I have to cancel that, so I have to undo that, perform the compensation, issue another event, and so on and so forth, right? And then the trip is basically failed. That's kind of the choreographed approach. I always had kind of problems with that view personally. So when I look at that, especially in that scenario and a lot of examples, I'm not really happy with the picture because it's hard to see that flow. You never see that statically, so you have to reason about like looking into all the functions in order to see to which events they're listening in order to understand what event flow will happen during runtime. You probably can look into something like whatever distributed tracing or event monitoring tools, but that's kind of a runtime thing. And if it gets more complicated like that, it's sometimes very, very hard to really guess what's happening. I heard a really nice term. I didn't add the slide for today, but at the QCon in New York, actually, Phil Calando, he works, or at that time he worked at Meetup, he said they were suffering from the pinball machine architecture. That's kind of thing, right? So you throw in something and it dong, 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 and somehow you get a result. But it's kind of what the hell just happened, I don't know, right? So it's sometimes a bit hard to do. Whenever I discuss that, it's like, yes, yeah, of course, because you're the workflow guy. You're having that tool and your tool is not there. Of course, you're not happy with that picture. That's very often the objection I get. So personally, I was super happy when I saw that blog post from Martin Fowler in 2017 already, actually. But that's a time where at least ThoughtWorks seems to have made more experiences with event-driven systems. And he wrote, the danger is it's very easy to make nicely decoupled systems with event notification without realizing that you're losing sight of a larger scale flow, and thus set yourself up for trouble in future years. And that pretty much expresses my feeling about that as well. So I see it at least risky here. And you can make good examples. So whenever you want to change the sequence, that's actually the hard part. If you want to change something in the sequence, in this case, let's say I want to book what's the example here? I want to book the car before the hotel because I got a good deal with the rental agency, right? And by the way, it's not unintentional here that I ordered the function calls. Because for the saga, it's very often beneficial here to have it in a sequence which is ordered by risk, because canceling the flight is much more expensive than canceling the hotel, right? So there's a reason for doing that. So there might be a business decision to change that sequence. And if you want to do that, you have to, I don't make the whole exercise here, but you have to touch on each and every function, because you have to change to which events they are listening. Right? And then you have to redeploy the functions, and you have to coordinate that, because you have still like trip bookings flowing around in the system. So you have to think about, okay, for that trip, did I already book the car or not? And you have a versioning issue. So it's not easy to do that, right? For me, and that's kind of what I said, I'm a metaphor guy. I'm using that very often. So whenever you're seeing talks about choreography and event-driven, it's kind of the holy grail at the moment. So it's kind of this picture, right? You don't have a central conductor, but you have these professional dancers or services or functions, and they know what they do, so it's a beautiful dance. And whenever you need some more people, you add just one dancer, he knows what it does, and it's beautiful. It's not exactly what I'm seeing out there when I see companies doing that. It's kind of sometimes hard to manage or chaotic what happens there. It's hard to predict. I'm not saying that choreography is a bad thing. It's kind of, you have to think about the use case you have at hand. And for some use cases, choreography is really good. I have another talk, which I don't give today. On my homepage, I have a recording where I give examples for really good use cases of choreography. But I think there are a lot of use cases where it doesn't fit, and then you probably shouldn't do it, because then it's just the wrong tool at hand. What's the difference here? If we look at orchestration, for example, how does that look like? So we could have a trip function here. It gets a request. Then probably, and that's a big difference, then this function basically like tells other function, it commands other functions to do something for it. It wants something to be done. That's orchestration. Like choreography means it produces an event and doesn't care what happens with it. And that's not the case here because the trip service is responsible for booking the trip. So it's interested that the hotel service does something for him, right? And then it could wait for the response, and because it wants to do everything in a sequence, it controls that sequence, it manages it. That's one point where it can understand it, where it can change it, because then it says, hey, car service or car rental does do that, and then probably at the very end, the flight service. Okay. And then you have that one point where you can really reason about the overall like workflow that's happening here. Right. If you want to change something, it's one point where you have to look at. Right. Okay. That's orchestration. And what I said earlier, you have to balance both. There are use cases for both. I mean, today I focused a bit on, you probably guessed that orchestration is a good idea here. Nice. You can do that with workflow if you like. So this is independent of how you implement it. So now we basically could go back to the very start and say, okay, now this is a function and you can hard code it. But because of all the reasons we already talked about, I probably don't want to do that, so I might want to use a workflow engine. And then you can end up with this. This is, again, BPMN. And BPMN, for example, in the language, BPMN is just the ISO standard definition of a language for workflows. And it defines something like a so-called compensation. You probably remember that, some of you at least, that's a rewind symbol, like rewinding the tape, right? That's where it comes from. And then you can, like, the workflow engine keeps a record. It keeps track of which activities were executed. Okay, I already booked the car, okay. And then you can trigger, whenever you have a failure, you can trigger the compensation, and then the workflow engine knows which compensating activities it has to do. In this case, it's calling another function, for example. And again, do I have it here? No. Again, it's stateful. And that's another important thing. Again, the workflow engine can wait for this function to come up if it's not available at the moment. So it's stateful, right? Good. I wanted to do some quick, okay, live hacking is probably too much. It's a live demo. Hacking is 5 minutes. It's not enough time. But I wanted to give you an idea how that could look like. And I have a slide on step functions later on. But for today, I wanted to use zeebe, which is basically our thing. It's a Camunda cloud if you want to have it hosted. And wanted to show you exactly what we had here. So what I have in the background, and actually I have the same thing with AWS Lambda. So if you want to check it out with Lambda, I have that on GitHub. On GitHub, I also have a recording somewhere linked, probably one step down, where I do it with AWS. But I thought AWS is too boring for today, so I wanted to do Google Functions. So what I have here is Google Cloud Functions. I have a couple of these functions already ready, basically to book the car, to book the flight, blah, 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 and to cancel them, right? So that's one of the ideas here. And then I have my whole book trip function. What does a book trip function look like? Let's go into that. Actually, I didn't use all the best practices to write proper functions here, so bear with me. It's everything in that thing, but that's easier to understand sometimes. So I have the book trip function. It's JavaScript here. So what I do is basically, in this case, now I use the workflow engine. That's what I said. I'm using zeebe here. It's open source, so go for it. Basically, I'm using a Camunda Cloud account. We're currently in a private beta, so you can get an account as well. What you can do there is you basically can create a cluster. A cluster is a workflow engine as a managed service, so you don't have to take care of how it's working. And then you get, like you know it from other things, like you get all the credentials in order to log into that cluster. That's basically what I provide here. And then I can create a so-called workflow instance of the trip booking service. The trip booking workflow. What's that? So if we go back, there's a trip booking workflow. And if we open up that, there's a special modeler for that. Then you see that I model it a bit differently, but basically I have also the compensation here. I book the hotel, I book the car, I book the flight. What's behind that is currently it's an HTTP connector in order to connect to my function. So there is the base URL, which I provide as environment variable later on, and that's the function I want to call. Yeah, that's one way of doing it, not the only way. But that's a relatively straightforward way. So I have all my functions connected. That's one thing. Right, no, that's basically the thing here. And it started from that one function. And then I'm basically done. It's not doing much more here, right? So I can call that. Let's go for it. Where's my bash? Where's my bash? There it is. So basically what I can do is I can now call that function on my Google account. I'm sending over a payload. The payload is pretty dumb, actually, but I think you get the idea. So I can simulate failures. That's actually the whole business logic of all the other functions, that they can throw errors when they're asked to. When I don't do that, if I send that over like without doing anything, what I can see is a couple of things. So first of all, workflow engines have kind of a tool, like a UI, so I can look into that here. For example, can see what's currently going on. Hey, there's a workflow instance in the trip booking service. Let's look at, let's look at version 2, because I know I don't have too much data in there. It's already completed. That makes sense, right? So there's the one I just started. And then I can see, for example, what it exactly did, like in which order and what happened there. I can see the data. That's normally where people are getting the idea of a workflow engine. It's stateful, it's a lot of data, it's working. But it basically went right through, right? So that's pretty cool. If I change that, if I say the flight is not working, then just to prove that it's working. Then if I go back, what I can see is now, refresh that. I have a new instance, this one, which basically ended up in the trip booking failed, and then the same thing. You can see that it canceled everything and walked through all of these kind of things. There's one thing, do I have, yeah, probably that's still working. Let's see, I didn't check that in advance, but let's assume I delete a function. I do something evil, right? I delete the function and then it's gone. Eventually consistent. Sooner or later it should be gone, hopefully. Because what's interesting then is that it's really a difference also like how you handle these kind of failures, what I said earlier on. Like one thing is you get back a, hey, we couldn't book that car. That's kind of a business error. It's kind of not the happy case, but it's kind of an expected case. But this is an unexpected. That's a technical problem. So there's, I don't want to compensate for that. I don't want to model for that. So then the behavior is different, actually. So if I look back at operate, I actually should see an incident. I didn't. That's interesting. Let's see if we have a bit of time to debug that. Which one did I delete? Do you remember? I didn't. Cancel the flight. What I normally happens is that that's a copy-paste error. Yes, it's a copy-paste error. I booked the flight again as a compensation, which is probably business-wise not the best idea to do, so don't try that at home. So actually what we have to do is we have to say that, we have to redeploy that. That gets a bit unhandy because I need to remember the URL of that. I don't have prepared the right command for that. Let's don't do that. Then you would see, I tell you what you would see if I do that. You would see a new version of the workflow coming up. That's another thing, like we keep track of the versions. So some workflows might run for longer, so they keep running in the old version. And by the way, this is not only for that tooling. That's kind of what workflow engines do. So even if you're running on whatever AWS or others, they're doing kind of similar things, right? So what I used here is zeebe. Try it out yourself. The architecture that's what I showed you. Basically, that's running as a managed service. I go through the HTTP gateway calling the function. It's not the only architecture. I have a blog post where I show different architectures to do that. We had a talk at a conference in Germany on Tuesday where Universal Music was explaining how they use that to orchestrate lambdas on a big scale. So that was kind of an interesting one. It's unfortunately not recorded, but I can share some infos if you're interested, so just talk to me. One thing I wanted to discuss, and that's kind of the last thing here, is about these graphical models. So I'm using that BPMN thing, and I'm actually a huge fan of BPMN, and that normally needs some kind of explanation, because a lot of people currently are in that mood of, wow, graphical format, no, we don't want to do that. We did that with the model-driven thingies like 5 years back, 10 years back. That didn't work. We want to do everything in code. That's currently the trend. And I actually normally then I pull out that one. That's a blog post from Clemens Fasters. He works at Microsoft. He also worked at the Cloud Events back. He's a pretty good guy, so it's not about Clemens, not at all. But I like the blog post in a way. It's the same example, right? That's what I meant. Everybody is doing the same examples. So this is the same example. And he basically explained how he implemented that, right? So we basically explained this and that, right? That's the code. But he starts with a picture. Of course he starts with a picture, because otherwise you don't understand what he's doing. You need to have that picture in mind in order to understand the rest of the code. And that's what I see people doing when they code it. They draw at the whiteboard, and they need to explain a lot of things in order to get going. And that picture here, like this one, that's, Microsoft's are probably PowerPoint. It's outdated the moment he uploads that, right? That's what we all know. And that's why I'm such a huge fan. If you do things like with BPMN, for example, that's kind of really, it's living documentation. That's the code. I haven't shown you that, but in the background, it's a simple XML file. So you can put that into your version control. You can diff it. You can even, we have a graphical diff as well, but you can diff it. You can merge it. So it's not an alien. It's nothing artificial, but it's like readable by normal folks and even like very different stakeholders. I call that biz dev ops. Like very often people think about like business folks, discussing requirements, which is important. Yes, and getting even more important, I think, because we have these distributed systems and problems, technical problems, which need a proper business answer. Can I ignore that I probably booked the hotel? Or what's the compensating activity here? Do we need to do that? How much time do we have? And so on and so forth. There are a lot of business things you have to discuss, okay? But that's obvious. But what I see much more happening is what I call then the DevOps thing, like the operations. That you're not having whatever, just a stack trace somewhere in a log file or an alert here or dead message there. You have something like, okay, there's the workflow. That's actually what I wanted to show you with the incident. You have that red lamp where you say, okay, here's a problem. This is the problem. That's the context there where it came from. And by the way, we have 100K of workflows with the same problem. So can you please fix that and go forward? And there, the picture helps a lot. If you look at step function, it does more or less the same thing. The language is not that rich than BPMN, but it does this comparable thing. It's just that for example, it doesn't give you that visibility thing. That's what I don't like about step functions at that point. Because especially if you think of more complex scenarios. I don't want to, sometimes people are frightened by that, but actually I don't use that much more symbols like I do, for example, I do a decision, I do a compensation, I do timeouts, and if you look at that for a bit longer, you're normally able to roughly understand what it does. And that's pretty cool, actually. Cool. As a recap, quickly, so function coordination might include orchestration, and that might mean workflow or workflow automation, workflow tools. Decide carefully if you want to do choreography or orchestration. Balance both approaches. And it's not a global decision. You can't say my company is going all in with choreography. It's a case-by-case decision. You have to make that very consciously. Don't use distributed transaction or anything. It's just not there. Don't assume that. So you need other strategies to handle that, like compensation, for example. idempotency is super important. That's why I took the time for the zucchini. Keep that in mind whenever you do a function. Make it idempotent. And yeah, that's more or less it. Thank you very much.